My name is Adam Norton. I am from the University of Massachusetts Lowell, the lead organizer for this workshop that is benchmarking robot manipulation, improving interoperability and modularity. And we've got our program today set up kind of in two halves, one kind of focused on interoperability and modularity, another focused on benchmarking. But really our aim is to cover both topics because we see a lot of ways that both can benefit from one another. So even though we're putting it into two separate sections, that's not how we're going to restrict our content. This is a quick look at the schedule for today. I shifted everything forward just about like 5 minutes, but we'll be flexible. We've got a series of invited talks, as well as 5 lightning talks from our contributions with posters. We got 2 in the first half for interoperability and modularity, and 3 in the afternoon for benchmarking robot manipulation. And then 2 talks from myself and Kostas Bekris at Rutgers that are going to cover some kind of components of the Compare project, which you'll be hearing a lot about today, that are kind of our motivation for some of the work that we're going to be discussing. So before we get into the rest of our program, I'm going to give a very short overview of the Compare effort, just kind of as some table setting. For the past couple of years, myself and my colleagues from Rutgers, WPI, Yale, and University of South Florida have been building a case for kind of improving the benchmarking and open source ecosystem in robot manipulation, finding a lot of evidence for the different limitations that exist out there that I'm sure all of us have had to deal with reusing code, not being able to effectively benchmark things, and determining some recommendations from the community for different improvements, such as organizing repositories of different material that you can access, or developing other types of pipelines and interchangeable software that can make it easier to conduct testing and reuse code. And just as like a bit of contextualizing of what we mean, at least me and my other project members, when we say side-by-side benchmarking, is we mean something where we're looking at, okay, some manipulation pipeline consists of hardware, consists of software, running a protocol to produce some form of performance metrics. In this case, this is just a grasping scenario. And when we say side-by-side, we mean taking things like our grasp planner and swapping it in and out within that pipeline for different types of capabilities, but also then taking that evaluation and running it on different embodiments, different hardware, different robot systems, whatever it might be. Now this is done a lot in the learning communities right now. There's a lot of kind of cross embodiment with data sets being generated and whatnot. We're trying to look at this kind of from the different open source components that get contributed. How can we evaluate their performance as part of these pipelines? So there's a lot of different types of components that exist within our open source and benchmarking ecosystem. Most of what we're going to be talking about today is more on the software side for perception, grasp planning, motion planning, et cetera. But we also need to consider the different benchmarking protocols, the data sets that they generate, the object sets like YCB that I'm sure we all use, and all these things that are either open source or open access that sometimes people have a lot of difficulty integrating. But aside from just integrating them, typically people don't contribute end-to-end full-scale solutions as part of their research contribution. You might develop a novel grasp planner or a novel perception module. Yet in order to kind of properly evaluate that as part of a full experiment, you do need the rest of the pipeline in order to really show its functionality. So here's how we envision the future ecosystem for open source and benchmarking. And you'll notice I'm going to be talking a lot about grasping, just because picking and clutter and grasping, very elemental, fundamental problem in this space, but it's kind of where we're starting. So let's say, for example, you want to develop a new grasp planner, and you need to add perception and motion planning. So you are going to ask yourself, what's available? Which ones are the best? How do I easily integrate them? And in order to answer those questions, you need to have a repository of modules that you can select from, maybe a leaderboard of algorithms so that you know which ones are the best for your particular scenario. And for integration, some type of standard interface to pass information would be very helpful. So what we take this to mean is, all right, we need some ready-to-use manipulation pipeline and resources that others can reuse in their work. so that we can enable some easy development and modular solutions. So, okay, we've got our simplified development, we've got our modular solution, but now I need to be able to assess it. So now I want to assess its performance, and I have another round of questions. What procedures do I use? What metrics do I use? Which algorithms do I compare it to? And how do I easily implement it in my lab? This brings up another set of potential solutions. Experimental protocols that are standardized, benchmarks, leaderboards, assuming that some of the other algorithms you want to compare to are open source so you can deploy them. But they can't just be open source because everyone uploads their code to GitHub, but does anyone reuse it? Is it documented well? Does it have standard interfaces? Probably not. So we need to also improve how easy to use it is. But with all of that in place, it will enable more quantified and informed performance comparison. So in comes our solution to this, which is a community-based effort we've been running for the past couple of years called Compare, Collaborative Open Source Manipulation Performance Assessment for Robotics Enhancement Ecosystem. And even though our title is very broad in terms of robot manipulation, we are starting with this initial use case for picking and clutter. As part of that project, we are trying to consider this entire kind of ecosystem of open source and benchmarking products, including performance evaluation and simulation or physical, and how all of that kind of informs the development of open source back through the cycle. As part of that, we are developing a lot of infrastructure towards different standards and guidelines that we can follow for developing open source and benchmarking, online resources like robotmanipulation.org or our Slack channel, which I'm sure all of you have probably been berated to join from me, and this will end with another call for you to join. But also a lot of test and evaluation procedures in order to do performance assessment analyses and usability analyses. Same thing on the benchmarking side, where you're starting to develop leaderboards, more standards and guidelines for conducting effective benchmarking, et cetera. And again, there'll be a lot of ads for robotmanipulation.org, robotmanipulation.org, robotmanipulation.org throughout this workshop. We'll be showing off kind of some of the functionality in a couple of the talks today. But this is really this very user-driven, community-based site. So we're building all these different repositories and assets that are organized, trying to make it easy for people to find the different open source assets they want to use. But we can't build it alone. So if there is work that you've come across that you want to contribute, or your own work that you want to get in front of a bigger audience, we would love to highlight it. So please check it out. And then there is my official call for joining the ecosystem. We have our Slack channel, or Slack workspace with a lot of channels kind of for different discussions, and then a Google group, the QR code on the right, which more functions as a mailing list.